Hello, welcome to Maths is Not a Mystery. Today we're going to be looking at the y equals mx plus c formula again, looking at gradients and straight line graphs. But what we're doing today is we're moving ahead to a slightly more difficult section where we're going to find parallel lines. Now we have a video of parallel lines today. We also have another video about perpendicular lines which follows on from this one, both of which are variants on y equals mx plus c. And you can see there that we've written y equals mx plus b. That kind of denotes that it's a different version of the same thing. And this time, as I said, we're doing parallel lines. Now, there's a graph, and the graph is the graph of y equals 2x plus 2. You can see how that works, can't you? The plus 2 there is the y-intercept at 2. And the 2x is the gradient, which is 1 along and 2 up. So I've sort of done it as closely as I can without actually measuring it on there. And now we're going to look at the question. And the question says, find the equation of the line parallel to y equals 2x plus 2 that passes through the point 2, 1. So what we're looking for is a line that's parallel to this, and it goes through a specific point. It goes through the point 2, 1 there. Now we need to know its name. Okay, now let's think how we're going to do this. If you think about the y equals mx plus c, the 2x part is the gradient, isn't it? The 2x is the gradient. The 2 stands for 1 across, 2 up. Every line that's parallel to this line will have the same gradient. It will always be 2x. It's the next part that's complicated. So y equals 2x plus 1 will be parallel because it will go through 1 on the y-axis. Y equals 2x plus 5 will be parallel. It'll go through 5 on the y-axis. Y equals 2x minus 3 will be parallel. Goes through minus 3 on the y-axis. Anything that begins with y equals 2x is parallel to that line, but we need to know precisely which line will go through the point 2, 1. So let's take a look at how we handle that. We're going to do a little formula. We'll come back to the graph and put the line on it in a moment, but we're going to follow this little formula for y equals mx plus b. And this formula is y minus y sub 1 equals m times x minus x sub 1. Now y and x are the numbers that we already have in our current graph. Y sub 1 is like the new one. It's the new substitute. It's the new graph that we want. The x sub 1 is the new x coordinate. Now let's just quickly go back and look at what the question asked us. It said that it needs to pass through the point 2, 1. Now bear in mind here that 2 is the x coordinate and y is the 1 is the y coordinate. Let's write these down then. So 2, 1 is the x and y coordinate that we're talking about. So what we're going to do is we're just going to follow this basic formula. Y minus, now y sub 1, the new y is this, isn't it? 1 equals, now what was the m value? The m value on here was 2, wasn't it? 2x. That's the m value. So the 2 remains the same. 2 lots of x minus, the new x value is 2. And so that's our new little part of the formula where we plugged in the numbers. Remember that if any of these numbers had been negative, then y minus the new number would have turned it into a plus. It would be minus minus, but these are positive anyway. Now let's just expand those brackets. Y minus 1, can't be changed, equals 2x minus 4. All right, 2 lots of x, 2 lots of 2 lots of minus 2. Now, we need to get the y on its own, and in order to get the y on its own here, we're going to add 1 to it, because then that's just y on its own. we need to add 1 to this side. So we've added 1 there. We're going to add 1 over here. So this would be y equals 2x, add 1 to minus 4, becomes minus 3. And that's our new graph. That's now in the form of y equals mx plus c, y equals 2x minus 3. So if we now go back to our graph and we just write down what it said, y equals 2x minus 3, well, that's going to be our new graph. Trying to do my very best at getting it parallel and going through minus 3. That will be our line that goes down there. It goes through 2, 1, and it then passes through minus 3. And obviously if you'd done that with a ruler, you'd be able to see that it worked exactly right. So that's how you find parallel lines. As I said, we do have a video about perpendicular lines as well. Similar kind of idea, but just slightly harder. Hope that's helpful. Thanks for watching. See you again soon on Maths is Not a Mystery.